Pre-Calc, we are moving on to our last note sheet for the year. Well, actually, I lied for just this chapter. But it's the last note sheet for Chapter 2. We are doing 2-4, Day 2. All right, and actually it's mostly review because we've done this before. We've talked about rates of change before, and so that's what we're going to be talking about today again. We've got find the instantaneous rate of change for f of t equal to 2t squared minus 1 at t equals 2. Interpret the answer if f of t represents a position function in feet of an object at t seconds. So instantaneous rate of change is something that we talked about before. Instantaneous rate of change is where you are finding the rate of change at a very specific time. All right, we did average rate of change before where it was, find the average rate of change between, 1 second into takeoff and 5 seconds into takeoff. This is instantaneous. When it's instantaneous rate of change, remember you have to find the limit as h approaches 0 of f of t plus h minus f of t all over h. All right, so that's what we're going to be doing in this problem. We're going to be doing the limit as h approaches 0 of f of t plus h minus f of t all over h. So we're going to replace the t in this function with a t plus h. So we will have 2, instead of t squared, it'll be t plus h squared. All right, minus 1. And then we've got minus f of t. f of t is 2t squared minus 1. And again, it's all over h. And I forgot to write limit as h approaches 0 in the front. All right, so what we're going to do is we're going to distribute or multiply the t plus h quantity squared out. All right, so you're going to have the limit as h approaches 0 of, if you do t plus h quantity squared, you're going to get t squared plus 2th plus h squared. And then we're multiplying it by 2. All right, so I'm going to write that down here. When I distribute the 2, I get 2t squared plus 4th plus 2h squared. Then there's still that minus 1 there. And then this negative is going to get distributed to everything in the second parenthesis. So we get minus 2t squared plus 1 all over h. And you'll notice that some things are going to cancel out. The 2t squared and the minus 2t squared will cancel. The minus 1 and the plus 1 will cancel. So we're left with the limit as h approaches 0 of 4th plus 2h squared all over h. And you'll notice that the h can be reduced as well. So this is really the limit as h approaches 0 of 4t plus 2h. The one h cancels out with the other h squared. So when we do the limit of as h approaches 0, this thing is going to be going to 0 because if you plug in 0, that becomes 0. So you're really left with just 4 times t. Well, t we know because it tells us right here that t is 2. So it's really 4 times 2. You're going to get 8, and then just don't forget units. It would be feet per second. So that's the speed 2 seconds into whatever this equation represents. It's going to be 8 feet per second. Now, if you don't like doing it this way, the other option is you could, since we know t is 2, you could do that right away. All right, you could plug in 2 right away. Plug in t equals 2 right away. And I'll show you that real quick. All right, so what you could do is you could have the limit as h approaches 0 of, instead of f of t plus h, you'd have f of 2 plus h minus f of 2. Let me erase that. I didn't write that. F of 2 all over h. All right, and then what you can do is you can kind of plug that in. So you'll have the limit as h approaches 0. If you plug in 2 plus h into here, you're going to get 2 times 2 plus h quantity squared minus 1. And then you have minus f of 2. f of 2, you can plug that in. All right, you're going to have 2 times 2 squared minus 1. And again, it's all over h. And you can simplify this a little bit. All right, you're going to end up with, if you do 2 plus h quantity squared, If you do 2 plus h times 2 plus h, you're going to end up with h squared plus 4h plus 4. So, and then you're distributing a 2 to it. All right, so you're going to be multiplying this thing by 2. So you're going to end up with the limit as h approaches 0 of, if you distribute the 2, you get 2h squared plus 8h plus 8. There's still a minus 1. And then this you can simplify. 2 squared is 4, times 2 is 8, minus 1 is 7. All right. So 4 times 2 is 8, minus 1 is 7. And then there's a minus sign, so it's minus 7. All over h. And then we can combine the 8 minus 1 and the minus 7, which actually they're going to cancel, because you end up with 8 minus 8. All right. And you can also reduce the h's. So the limit as h approaches 0, if you divide 2h squared by h, you get 2h. And 8h divided by h is just 8. When you plug in 0, this goes to 0, and so you're left with just 8. So you'll notice either way you do it, you're going to get 8. So the answer is 8 feet per second. It's just a matter of, do you want to plug in t equals 2 right away or wait till the end? It doesn't matter. Either way is fine. You'll see you get the right answer. For number 2, same idea. It's just a little bit different. It says find what is the rate of change of the volume of a sphere. So volume of a sphere, that's going back to geometry, with respect to the radius when r equals 2. Okay, so the volume of a sphere, if you remember it, great. Otherwise, you can look it up. But the volume of a sphere is 4/3 pi r cubed. Okay, that's the volume of a sphere. And what we want to do is find the rate of change when the radius is 2. All right. So it's kind of like the last problem. You can either, we're still going to be finding the limit. We can plug in 2 for r right away, or we can plug in 2 at the end. It's your choice. Just like we did up here, we plugged in 2 for t either right away or we waited. So what we're going to do is we're going to be doing the limit as h approaches 0, and instead of t, we're going to use r. So it'll be f of r plus h minus f of r all over h. All right, and I'm going to wait till the end to plug in the r equal to 2. You could plug it in right away. Either way is fine. So we're going to end up with the limit as h approaches 0 of, if you plug in r plus h into this equation, you're going to get 4/3 pi, and instead of r cubed, it'll be r plus h cubed, minus f of r, which is just 4/3 pi r cubed. And again, it's all over h. We need to multiply r plus h 3 times. So I'm not going to do that work off, but hopefully you can handle that. R plus h cubed, if you multiply it all together, you're going to get r cubed plus 3r squared h plus 3rh squared plus h cubed. All right, you have to do r plus h times r plus h, and then multiply that by r plus h. It's a lot of work. So we've got this. So we're going to have the limit as h approaches 0 of this 4/3 pi times this thing, the r cubed plus 3r squared h plus 3rh squared plus h cubed, all right, minus this 4/3 pi r cubed all over h. So there's a lot going on here. What we're going to do is distribute the 4/3 pi to everything inside the parenthesis there. So we're going to end up with the limit as h approaches 0 of 4/3 pi r cubed. 4/3 times 3 is just 4, so you get 4 radius squared times height times pi. Okay. Plus 4/3 times 3, you're going to get 4 radius height squared pi, and then 4/3 pi h cubed minus 4/3 pi r cubed. Again, it's all over h. Right? And so what will happen is we have 4/3 pi r cubes that are going to cancel out with each other. Right? And we can reduce each of these 3 terms, and the top can all be reduced and divided by h. So we get the limit as h approaches 0 of this one, the h's will cancel. So you get 4 radius squared pi. This one, the h will cancel, and the other one just becomes h to the first, so 4rh pi. And the last one becomes 4/3 pi h squared, because we're dividing by h. Now when we plug in h equals 0, this is going to go to 0, this is going to go to 0. So you're left with 4 radius squared pi, or 4 pi r squared. We know that the radius is 2, so we've really got 4 times 2 squared times pi. 4 times 4, you're going to get 16 pi. All right, so that's going to be the rate of change. It's going to be 16 pi. And then our units, all right, we're talking about the inches, the volume in inches, and the radius in inches. So it'll be cubic inches of volume per inch of the radius. All right, don't worry so much if you didn't know what the units were supposed to be. That's not a huge deal. It's more the answer, 16 pi, that I'm more interested in. Okay, the last problem is talking about continuity. All right, it says to find the value of k that makes the function continuous. And so you'll notice it's a piecewise function. And in order for it to be continuous, we want to make sure that there's no gaps in the graph. The only place where there's a potential gap is right here where x is equal to 2. So what's going to happen is we want whatever the y value is for this top branch at x equals 2, we want it to be the same as the y value down here when x equals 2. So what I'm going to do is I'm going to plug in 2 into the top function. I get 2k plus 24. If I plug in 2 into the bottom function for x, I get 2k squared. Again, I want the y value to be the same for both of them. So I'm going to set them equal to each other. And then I'm going to solve for k. So I'm going to bring everything over to the right so that k squared becomes or stays positive. All right, so minus 2k minus 24. I can factor out a 2, k squared minus k minus 12. We can factor that. It's going to be k minus 4 times k plus 3. And then you set those things equal to 0. You're going to get k equals 4 and k equals 3. So, sorry, negative 3. So those are going to be your answers, k equals 4 or k equals negative 3. You want the y values to be the same, so we figure out what the y value, what that k value would make our y values the same. All right, and that's it for 2-4. We are done.